Okay, let's go ahead and get started on this video real quick. This is on a double replacement reactions, and when you have a double replacement reaction on there, what you are always going to have is a compound plus another compound. And I'm going to abbreviate because I'm going to run out of room, and it will make a new, new compound plus another new compound. Now, the way that this happens, so if you'll look at kind of at my color coding here, you will always have in the beginning, when you write a compound, you will always have the cation first, the positive first. So in both of these, we have our positive. So again, a cation is an ion that has lost or given up electrons. Therefore, positive in charge. Okay, and cations are always, guys, going to be your metals. Okay, your metals are going to be your cations. Our anions are always written second. Okay, so an anion is an ion that has gained electrons. Okay, so when it gains an electron, it gains more negatives, so it is negative in charge. Okay, and the ones that want to do this are your nonmetals. Okay, so you need to remember those two facts, anions and cations. Now, when I come back up to my compound, we also know that by a rule is that opposite charges, let's say, attract. Okay? If they're the same, they repel. So when I look up here, I have a positive A. So when it goes to attract, it is going to attract to the negative on the other compound. So this is still, whoops, change my colors. So we're still going to have the positive A with the negative Y. Positive, negative, all the time. And so we're going to have our positive B with our negative X in this case. So you're going to just swap places, but remember, opposite charges attract. Opposites are going to be put together when we have this. Okay, let's do an example here, and I misprinted this. It is K2CrO4. It was kind of hard for you guys probably to see that. So when I come here, I have silver, okay, that is a, make sure I have the right color, a positive 1 in charge. I have nitrate, which is a negative 1 in charge. I have potassium, that is a positive 1 in charge. And if I don't know what chromate is, well, it took 2 potassiums. There's positive 2, so chromate must be a negative 2. And so I would always write theirs. Now, when I showed you the single replacement, I told you it went from an element that had a 0 charge to a compound, which then, or a cation or anion that did have a charge. In this case, the charges are going to stay the same. And so we're now going to have, okay, the positive silver is going to attach with the negative chromate. Again, I'm going to check my charges here in just a minute, but I'm just going to do the switcheroo first. Plus, I am going to now take my positive potassium with my negative nitrate. Now, we've talked about multiple times not taking the charges or not taking the subscripts with them. That subscript is to balance that compound. Now I'm going to go back and look at my charges to see if I need subscripts. Silver is a +1. We said that chromate was a -2. That means I am going to need a subscript of a 2. I have potassium, which is a +1. I have nitrate, which is a -1. And again, I'm not going to need any subscripts, so I'm good and done. Now, the next thing we're going to look at is our solubility table over here. Will this reaction actually take place? If that is going to take place, then one of these has to be insoluble. So I'm going to try to find these, and let's see if we can find silver chromate. So here's chromate. So I'm coming across here, and I want silver. Let me come down silver's column because I have a hard time. And so it does say that it is insoluble. So that means that this is going to be a solid. Let's look at our potassium nitrate. So we have nitrate, and again, we've talked about this, how they're all pretty much insoluble, and potassium is here. Soluble. And so yes, that is soluble. That means this is going to be aqueous. Okay, so that reaction did take place. Okay, let's do another one. So potassium again is a right color. Potassium is a +1. Iodine is a -1. Nitrate we know to be a -1 here. So that gives me a -2, which means that my lead has to be a +2. If you don't understand how I just did that, that's probably something that you need to check on. Again, I'm going to do a switcheroo. So I'm going to take the positive potassium with the negative nitrate. And this one we've already just did, so we know that is an aqueous solution. Okay. Let's go ahead and do the next one. And so I am going to take the positive lead, which is a 2, with the iodine, which is a -1, so I'm going to need 2 of those. So let's go over here and check our lead iodine real quick and just see if it is in fact soluble. So we're going to do lead and iodine. So here's my iodine. Where's my lead? PV, there it is. So we are insoluble. So very good. That means that this is going to be, oops, wrong button. Let me erase that if I can without messing up the iodine. Fix that. And again, this is going to be our solid. I ran out of room. We'll do one more. So again, we've got our calcium. That is our positive. Calcium is a +2. We've got our hydroxide, which is a -1. Hydrogen being a +1. Chlorine being a -1. Okay, and again, if I'm going too fast on those, you can definitely pause and check it out. So again, I'm going to take my positive calcium with my negative chlorine. Now calcium is a +2, chlorine's a -1, so I'm going to need 2 chlorines. I'm going to take my positive hydrogen here with my negative OH. Okay, and hopefully you recognize that as water. So we know for sure water is going to be a liquid. It's not going to be a solid here. And so I just need to check my calcium chloride. So let me get that here. So here is chlorine, and I need calcium. Right there it is. Okay. So calcium chloride is soluble, okay, which means that this isn't, whoops, I did that again, which means that this is in fact another aqueous solution. So I have an aqueous solution and I have a liquid, which means that really we're going to see no reaction here. Okay, so that again is going to sum up your double replacements. We'll also take a picture of your solubility table and maybe tape that on top of there so that you have that.